And the question I want to answer now is, why would we want to factor? Why would we do such a thing? Right? What is the whole purpose of us learning how to factor expressions? So what I want to do is imagine, for the moment, that we have factored each of these. So you told me a moment ago how to factor x squared minus x minus 42. How does it factor? Negative 7 and positive 6. X minus 7 times x plus 6. You also told me how to factor x squared minus x minus 2, but we're going to come back to that one in a moment. I'm going to kind of move it down a little bit. How does that one factor? X minus... So in order to get the product to be negative 2, we need x minus 2 plus 1. And then the sum is equal to negative 1. All right, so this was the skill that we just worked on, right, is how to actually do these steps, how to factor a quadratic trinomial into a product of two binomials, right? We would call these binomials, each of them, because they have two terms. So why is it that we factor? Why do we care about all of these things? Why we care is because I want to imagine for the moment that each of these factors, x minus 7 and x minus 6, is some number, right? Depending on what the value of x is, x minus 7 is going to have some value, which is 7 units less than it. X plus 6 is going to have a value which is 6 units more than it. And now let's imagine that we're solving an equation. Like x minus 7 times x plus 6 is equal to 18. So what we're really asking for is for values of x which have the property that when I multiply this quantity by that quantity, the result is the number 18. So let's rewind the tape and ask, what are the different types of numbers we could multiply together to give us 18? 6 and 3. So one way of doing this might be to imagine that x minus 7 is equal to 6 and x plus 6 is equal to 3. Right? So this is a possibility. Granted, it's not exactly going to work because x minus 7 and x plus 6 rather, have to be 13 units apart. So that's actually a little bit challenging. But so 6 and 3 aren't going to quite work. But we could also have 9 and 2. Could have negative 9 and negative 2. Those still aren't 13 units apart. We could have 18 and 1. I shouldn't say 18 and 1 around a Patriots fan crowd. I hope no one takes offense. Well, let's call it 1 and 18. Maybe that sounds better. But none of these are going to work, right? That if we tried to make it so that 18 and 1 were the factors here, those aren't 13 units apart like x minus 7 and x plus 6 are, so they're not going to work. The other problem is that we're not requiring that x be a whole number here. So there are a whole bunch of other ways to multiply two numbers and get 18. We could do 36 and 0.5 is another possibility. We could do negative 180 and negative 0.1. That's a possibility. There are whole lots of nasty possibilities for how to do this, which is why we don't use factoring to try to solve an equation that looks like that. There's just too many possibilities for what each of these factors could be. That's the bad news. The good news is, there is one number that we could put on the right-hand side of this equation for which we immediately restrict the possibilities on what can be on the left-hand side to only 2. What I mean by that is that there's one number I can put on the right-hand side of this equation that will allow me definitively to say what these two factors must be. There's only one real number for which there is a finite number of ways we can factor it. What is it? 0. 0 is the one real number that tells us what its factors are with absolute certainty. How does it work? Well, how do I multiply two numbers together and get 0? Yeah, exactly. The only way to do that, and 0 is unique in having this property, the only way to do that is to have one of them in the first place having been 0. So there's only two possibilities. Either this one is 0, or this other one is 0. It's the only way. Because if neither one of those two things is true, if neither x minus 7 is 0, nor x plus 6 is 0, then on the left-hand side of this equation, I'm multiplying a non-zero quantity by a non-zero quantity, and that product is never equal to 0. So 0 is special. 0 is unique in having this property. Math majors would say that the real numbers form an integral domain. It has no zero divisors. There is no way to multiply two non-zero quantities in a way that provides 0 as a product. So, why is this a good thing? What can I do according to this fact? Knowing that the product of two factors is equal to 0 means that one of the original factors must have already been 0 to begin with. And so what it does is it takes our one complicated equation and replaces it, splits it, into two much simpler equations. So if I rewind the tape all the way to the beginning, if I start with x squared minus x minus 42 is equal to 0, and we then factor the left-hand side, then because on the left-hand side I have a product of two numbers which equals 0, and because 0 is the only real number that has this property, we must know that one of the original factors must have been 0 to begin with. So either x minus 7, this one, must have been 0, or x plus 6, that one, must have been 0. If it's the former, if x minus 7 is equal to 0, what does that tell us about x? Yeah, just add 7 to both sides and we've solved that equation for x. X equals positive 7. If, on the other hand, x plus 6 is equal to 0, what does that tell us about x? Yeah, subtract 6 from both sides. And now we have discovered two solutions of this equation. If x squared minus x minus 42 is equal to 0, then either x must have been 7, because if x were 7, it would have made this first factor equal to 0, or x must have been negative 6, because then the second factor will have been made equal to 0. So this is actually the first example of a single equation we've seen in our course that has two different solutions to it. And our typical process of reversing the order of operations that we learned in the first half of the course would not have been enough to give us two different solutions. Factoring, on the other hand, can. And in this case, did. Sometimes there's a little more work to do before we get to that point. So let's suppose that whoever's writing the test that you're taking has given you an equation that looks a little different. That person's going to be me, so let's just say me. So let's say I give you this equation, x squared is equal to x plus 2. What do we want to do in that example? Okay.
We start off with the same process.
Okay. What does that look like?
1 times 2.
So yeah, so what you might want to do is start looking at the number 2 and say what multiplies together to give me 2, but which adds together to give me 1. Well, the only possibilities are 2 and 1, or 1 and 2, but both of those add up to give me 3. Or negative 1, negative 2, that gives me negative 3. So I can't factor this, and one of the reasons I can't factor this is it's not actually an expression, it's an equation. I have an equal sign here right in the middle of it. So before we should think about factoring, we should think about getting everything in this expression together. The other thing we should be thinking about is this what the little keymaster is here for, right? Factoring is not going to help us solve an equation unless one side of that equation is equal to 0. If one side of the equation is not equal to 0, factoring is completely worthless because it doesn't narrow down your universe of possibilities. It doesn't narrow it down at all. It's still infinitely many instead of 2, as you get when you factor, and have a 0 on the other side. So, if there is a mantra here, it is this. Never factor in an equation until the other side, let's say, is 0. Neither side of this equation is the number 0 right now, and so we shouldn't think about factoring just yet. Hold off. Restrain yourself. I know you'll want to start factoring something right away, but pause. In our first example, one side of the equation was 0 in the very beginning, so we didn't have to do anything special. We could factor right away as step 1. Here we have to do that work. How can I make one side of that equation equal to 0?
Subtract x plus 2.
Yeah, exactly. So just like in Module 2, where one of our questions was, how do we get all of the variables onto one side of the equation so we can isolate it and solve for it? The answer then is the same as the answer now. Move terms from the right to the left or vice versa by subtracting them. So if I want to move the x plus 2 from the right side to the left, what I want to do is subtract the x from both sides, and then also subtract the 2 from both sides. If I do both of those things, then on the right-hand side of my equation, what do I have left? 0. I've subtracted all of my terms from the right to the left, leaving me with no quantity on the right-hand side of my equation remaining. So I have my 0, which is what I want. 0 is, again, because it has that unique property among all real numbers that allows us to split the equation apart into two pieces, we want that 0. Before we even think about factoring, we need that 0. Because then, since I have the 0 on the right-hand side, that's when I would factor, do the process that you did a few minutes ago for this, to get it to be x minus 2 times x plus 1. And then what? What does factoring allow us to do now that we couldn't do before? Solve for x. How? What would you say is the next step here?
Setting both those terms equal to 0.
Yes. Right. So I like to think of it as factor and split. Winning the factoring battle is the first part of it. The second part of it turns out to be a much simpler process. After you split this equation into two pieces, giving each factor its own equal 0, then all we have to do is solve each of those two much simpler equations to find the value of x. For if x minus 2 is equal to 0, what is x? Positive 2, just by adding 2 to both sides. And if x plus 1 is equal to 0, x is negative 1 by subtracting 1 from both sides. Right. So the strategy that allows us to use factoring to solve an equation is a strategy of factoring and then splitting. But before factoring, maybe I should add one more clause, get your 0, find your 0. How do we want to say it? Yeah, get your 0. So the other side of your equation needs to be 0 before you even think about using factoring. But then once the other side of the equation is 0, factor away. Having factored, we can then split the equation so that each factor gets its own equal 0, and then those equations that you have to solve are much simpler to solve.